Hey everybody, thanks for coming to our session. Hi. This is GPSTEC326, the future of manufacturing. I am Tom Jones, otherwise known as Elvis, and both seems to be appropriate for being on stage at the MGM Grand. Actually, short story, I did get my picture taken under the Tom Jones marquee at the MGM Grand a couple of years ago. So I'm a solution architect for AWS, and my focus is industrial software. And today, well, first of all, what is industrial software, right? Industrial software encompasses a bunch of things, from design to simulation, engineering, supply chain logistics, and manufacturing operations. So we're going to have Dave Mitchell come up and tell us a little bit about Siemens' journey to the cloud. Dave is VP of Manufacturing Operations Management at Siemens PLM, but he's done all these things and is an expert in all of them. So we're going to benefit from his experience and wisdom in a little bit. Together, we're going to talk about the future of manufacturing and trends we are seeing in the industry and how our customers are using the cloud to take advantage of these changes. So, I also had AI in the title of this talk. So, when we're talking about these trends, I want to make sure we focus a little bit on AI as well, and what the impact AI will have on manufacturing. We'll take a look at how our customers are using AI today and where it might take us in the future. One of the, so where AI is impacting manufacturing, a couple of areas are through analysis, through decision making, and through automation. So let's start at kind of a high level though. So if we take a look at manufacturing, what is manufacturing, right? Well, maybe it's how to build a better mousetrap. But I really think about, or what I really want to talk about today, is how to better build a product. And when you build a product, you start with an idea, and you go through a process to actually build it, and then you take that product into production, you productize it. And let's look at these steps in detail. So the actual steps are through production design, through product design, through production design, and then into production. And these are made up of discrete steps that have tools that are associated with each step. So for example, we have computer-aided design in the design phase, computer-aided engineering for simulation. We've got things like civil engineering, computer-aided manufacturing. We see spans a couple of these steps, production planning, and more. So, but what I really want to, I just want to highlight that this is a complex process. But what I really want to do is talk about this process in the middle, this linear process that we see today, and how this is changing when we add in data and we add in analysis of that data. Right? So what we're doing is we're taking this linear process and changing it from a straight line into a loop. Right? This is now a cycle where the data that we're getting from products out in the field can feed back into the design process and inform the design process itself. And this is a key trend that's driving manufacturing. And we saw, who was in the partner keynote this morning? Oh, a third of the room. So you saw Siemens MindSphere there. So Siemens is, Dave will talk a little bit more about Siemens MindSphere, and this is one of the tools that's enabling this feedback loop. So what's driving this change? Well, it's data. Data is driving this. Data is at the center of this cycle, and we can take that data and we can wrap it in AI so we can extract more information out of this data. And then all of this is being controlled by humans so that the data and the AI is augmenting the work that humans are already doing with these tool sets in each one of these steps. So That's a high-level picture. Where are we today, and what are some of the trends and challenges that we're seeing in the manufacturing industry? Well, first off, let's start with the challenges. So we see some challenges around data, on-premises requirements, mass customization, and the increasing complexity of configuration, and competitive and economic pressure around the needs for faster product innovation. So let's take a look at each one of these in detail. So first is data. What's the problem with data? Well, or what are the challenges, I should say? The first is that data is in silos, right? We have different file formats, we have different physical locations, and of course that's exacerbated when you have acquisitions. Then we have an increasing volume of data. So, with all these devices and the increase in connectivity, we're seeing an exponential increase in the amount of data that's available. And, of course, we now have cheap storage, so you can store all that data. Why is this important? Well, data has value. The more data you have, the more valuable it is, and the more meaning that you can extract from it. Data has gravity. The more data you have, the more it wants to be together. Why does it want to be together? Because you can do things like extract that value, and you can build collaboration around it. It's much easier to build collaboration around data if it's all in one place. And it unlocks new business models, like SaaS, software as a service. If your data is in lots of different locations and different formats, it's hard to build a SaaS business model. So here's an example of a data lake built on AWS using S3, which is our simple scalable storage service, our object-based storage, as a data lake. So we see here data coming in from a number of different services, maybe Amazon Kinesis, for example, going into a data lake in S3, and then that is using ETL, or Amazon EMR to do ETL, extract, transform, and load on that data, and then putting that transformed data back in S3. Or you can take that data and use Lambda and our serverless applications or services to extract metadata and build indexed search through services like Elasticsearch. You can take that data and populate it out of S3 into Amazon Redshift to build a data warehouse, and they use something like Amazon QuickSight to visualize it. But one of the things that's really interesting to me is what we're seeing in the state of the art with this. This is pretty close. And we see down at the bottom here, Amazon Athena. Amazon Athena is really where I see this data lake going, the data lake evolution, where you're able to run Athena on top of data that you have in S3 without running any infrastructure at all. And you pay by the query. You can also use Glue, AWS Glue, to do the ETL if you don't want to run your own EMR cluster. Now today, this is limited to SQL, Hive, and Spark jobs, but that will evolve over time as well. Okay, so that was our first challenge. Let's take a look at our on-premises requirement. So here, we have challenges around uptime, right? Your factory, once that needs to continue operating, even in the case where you've got a guy with a backhoe. Okay, that's not a backhoe. That's the icon I had to use. Imagine that's a backhoe, right? Got a guy with a backhoe, right? In the cut-set connectivity, the factory needs to keep running, right? Or maybe the factory just has intermittent connectivity, or maybe it's got machines in it that were designed before there was an internet, right? They're not internet enabled. What do you do about that? Well, one of the approaches that customers are using is through AWS Green Grass. So Green Grass is a software service. This is software that you can run on your own devices. It'll run on a Raspberry Pi, but it can run on bigger things. And it allows you to essentially extend AWS onto your on-premises location, and then take advantage of the cloud as long as that connectivity is there. But it will continue to operate even if that connectivity is interrupted. And this image I have up on the screen is actually an image of a demo that we are putting together. It's not quite ready yet because the shipment was delayed. But check out in the ARIA later this week for this demo. This is a KUKA robot, industrial robot, being controlled by Green Grass running on a Raspberry Pi. And you can unplug the internet from that robot and it continues operating. Okay, another way that customers are addressing this on-premises requirement is through Snowball Edge. So Snowball was initially designed as a product to allow massive data transfers. With the Snowball Edge, we've included compute power. So the Snowball Edge has the equivalent of an M4 4XL built into it. So you can run Green Grass on a Snowball Edge on your premises. It's also clusterable, it's rack mountable, so pretty cool product. Okay, so that's our second challenge. The third challenge is around mass customization. And this is an example of mass customization, and I'm sorry that they didn't arrive, and I'm not wearing them right now. But this is a pair of Chuck Taylors that I made for myself that are a unique SKU, one of one, right? How do you plan for that? How do you plan for the fluctuations in your service when you don't know how many products you're going to be creating at any one time? And how do you simulate that, right? How do you simulate, this is a very simple product that probably doesn't need simulation, but if you have something maybe not significantly more complex, but maybe like a chair, everybody's sitting in a chair, how do you simulate that when you're allowing customers to custom build their own chair, one of one production? So your simulation size, or at least field, becomes larger. And then of course, we have complexity driven by massive amounts of configuration options. That's really what we see here. I just chose from a whole bunch of configuration options. So what are some of the ways that customers are addressing these needs? Well, we have a bunch of services to help address this, things like auto-scaling, serverless services, where you don't have to manage the servers, you don't have to worry about scaling them, you just upload your code and we'll take care of that. And all of these are dependent on having architectures that are built around loose coupling, things like microservices. So when you have architectures that are created through fungible components, that gives you the ability to manage this fluctuating demand, and there's no need to over-provision. And one of the examples of this that I wanted to highlight is this very busy image. Anybody know what this is? Okay, so this is a representation of the microservices that you hit when you load Amazon.com. So Amazon.com used to be a monolithic application. It's now thousands of microservices. And so I'm not just telling you what you should do. This is what we do on a daily basis. And how does this help? Well, it helps us be more agile in a number of ways, but probably the biggest way is it allows us to deploy quickly and respond quickly to customer demand, right? It allows us to create 50 million software deployments to production a year with Amazon.com. So another example of this, maybe a more concrete example, especially when we're talking about the factory and it needs to stay operational, is Siemens Active Workspace. So Siemens Active Workspace is a graphical tool that you can use to view and manipulate 3D models. So you can use it right through your browser. But Active Workspaces needs a GPU, right? To be able to do that 3D rotation and modeling, you have to have a GPU. So this is an architecture that Siemens came up with that creates a pool of GPUs in the cloud. And you can use this with Teamcenter in the cloud, but you can also use it with Teamcenter on premises. So it's kind of a hybrid model. It gives you that scaling, and it'll scale out those GPU P2, P3, or G2, G3 instances are in an auto-scaling pool, so they can scale out and scale back as you, with demand. Okay, so along with increasing complexity comes a need for increased communication. So how can you foster that communication, and especially when you have maybe a desktop application that is not cloud native? So we have a couple of services to help with this. Amazon Workspaces, which is our virtual desktop as a delivery service, and Amazon AppStream, which is an application streaming tool. Both of these both of these services are able to stream these either desktop or applications through a web browser. And it's a little bit small, but in this image there's a couple of Siemens products, Siemens NX and Siemens Solid Edge. And this is actually a screenshot of the demo page from the AppStream 2.0 service. So you can go and try these products today. Okay, and last but not least is the competitive pressure. So this is at the heart of being competitive in today's global market. The pressures, this pressure highlights the need and desire for greater efficiency. And there's a few vectors here, like agility, which we touched on just a minute ago, but there's a few more. So one that I like to call fiscal efficiency is this CapEx versus OpEx, right? So instead of purchasing new hardware, which is capital expense, you can buy what you need on demand in the cloud, and that's an operating expense. So your money is not tied up in assets that are depreciating over time, and it also allows you to have greater flexibility, because if your needs change, you can change along with those needs. It also means that the way business was done before is not necessarily the way business will be done in the future or is being done today. Here we're seeing technology like the impact of additive manufacturing or of new business models like SaaS, software as a service. And remember, data has value. SaaS is one way to capitalize on this. And we see this, for example, with the Autodesk Forge. The Autodesk Forge is a SaaS offering where you can build applications and utilize the intellectual property that Autodesk has built into their desktop products on an API call, or per call basis. I think it's really brilliant because it's a great way to build a new business without undermining the existing business that they already have. Another way to increase efficiency is through automation, through robotics. And here's a picture of a couple of really fascinating robots, Baxter and Sawyer. These are relatively low-cost robots, less than $30,000 US, and they can work alongside humans. Most of the robots, like the KUKA robots I showed earlier, are not aware of humans, and they're in fact in cages so you don't get hurt. These robots can operate right next to a human on a production line. And I believe, and what we'll see and what we are seeing is that they're being used to do tasks that humans don't want to do. It's either too dangerous, or it's too dirty, or it's too repetitive. And so the people who are working on the production line are like, well, if we can get a robot to do that, then I can go over here and do this other thing that's really cool. So I think we're going to see more and more of this. Even in existing industries, robots are going to augment humans. So, for example, my father, and this is quite a few years ago, my father worked in shipbuilding. And one of the most difficult jobs when you're building a ship is pipe fitting. So you've got pipes, and they're being put in constrained places, And you had very skilled welders who had to go in there and contort their bodies to weld these things. Well, they ended up buying a welding robot, and they had to train somebody and teach him how to use this robot. So the robot wasn't just off running on its own, but he was able to generate higher quality welds in shorter time, and it increased the efficiency of their business significantly and helped them win deals. So we're going to see more and more of that. So we talked about Green Grass, we talked about Snowball Edge. One of the other things that I want to touch on is AI and the AI services that AWS offers. So how does AI help manufacturing today and looking forward? So the services that AWS has that support artificial intelligence start with our infrastructure services. So we have services like EC2, our Elastic Compute Cloud, with our CPU-based instances or GPU-based instances, and now our FPGA-based instances. Those are F1 instances. All of those are designed to either match your workload or accelerate your workloads. We have other services like our IoT service and our mobile service, and we support all of the major frameworks for deep learning and machine learning. In our AI platform, we have the Amazon Machine Learning Service, the EMR and Spark, so EMR is Elastic MapReduce service. We have the AWS Batch service, which is a way to do batch computing, as well as the AWS Deep Learning AMI. So the Deep Learning AMI is an Amazon machine image that has all of these frameworks pre-installed. You can just start it up, create an instance using that AMI, and get to work with any of these frameworks really quickly. And then last but not least are our AI managed services. So this is Amazon Rekognition for image analysis, Amazon Lex and Amazon Poly that are speech to text and text to speech. And I'm hopeful that we'll see some more of these this week, if not before the end of the year. Okay, so what does that mean? If we go back to those steps we started with at the beginning when we were going through our design process, we start with design, we go into production design, we go into production. How can AI impact each one of these stages? Well, what we're seeing is AI has a big impact through things like generative design, on topology optimization and lightweighting of materials, through parameter tuning and materials optimization. Right? That's in the design process. In the production process, we're seeing automation and optimization and increases or the ability to increase safety. So a great example of that is using image recognition. Maybe you have a camera overlooking a construction site, and you've got a guy with a hard hat, and you've got a guy who doesn't have a hard hat. Well, that's a flag, right? That's a safety violation. That's a hard hat area. You could totally build that really easily with something like recognition. And then moving on into the data and analytics step, we have operational tuning and logistics management, quality control, and predictive maintenance. So when we talk about things like operation tuning, talking about taking a gas turbine, and it has many different input parameters that you could adjust, and taking that turbine, keeping the output the same, but lowering the emissions, right? That's something that machine learning is very good at helping to optimize. And then last but not least, going back, bringing that full circle all the way back into design through things like the digital twin. So building a virtual representation of not just one system or device that's out in the field, but an aggregate of all those devices, and understanding exactly how those devices are running in the field, and being able to simulate that. Right? This is this concept of the digital twin. And then taking that and moving even beyond that into what I call descriptive design. So to design today is very prescriptive. If you want to design something like this podium, you get out your CAD program and you draw it, and it's got to be this high, and it's got to be made out of this material. In the future, what that'll be is it'll be a designer working alongside an AI to say, hey, I need something to put my laptop on. And yeah, maybe I want it to be this high, but I want it to be optimized for portability. I want it to be optimized for lightweight. I want it to be optimized for manufacturability. Go make me 1,000 iterations of that design. And then it'll surface back maybe the top 5. And you can pick from that and start to refine that process more. So that's an area I'm pretty excited about. One of the other ways that and this is a great example, I spoke a couple weeks ago at the Autodesk conference, and I used this slide. This is a demo of a virtual assistant for a very complex CNC machine at Autodesk Pier 9 facility. And so it's kind of hard to see, but there's a little echo dot on the side of this control panel and an iPad. So it's both a verbal interface and a visual interface to guide somebody who's maybe not a skilled machinist in the use of this very complex machine. And it was all built using AWS serverless technology. So you could talk to the machine and ask it, what should I do next? And it will guide you through all those steps and tell you which of those, 50 buttons to push. It's pretty cool. The other thing, so I was just talking about descriptive design. The other thing that's really interesting is generative design. So, and what this is really doing is it's increasing the design space that an individual designer can work through. So here we see an example of a skateboard truck. And in this particular example, the skateboard truck, the design parameter was that they wanted to be able to use a solid axle. And of course, you see the hole there at the bottom for the kingpin to go through. There's a bolt that holds that on there. But it went through many different iterations of this based on the stresses that this particular object will be subject to out in the field. And then the designer can pick the one that they think is most appropriate for whatever manufacturing technologies they have. So in this case, this is the actual product. This was 3D printed, and this is upside down from those previous images. This is 3D printed out of metal, but I didn't get a good picture of it, otherwise I would have put it in here as well. I saw this exact same object made out of a piece of aluminum that was CNC milled on a 5-axis CNC machine. It was beautiful. So really cool, and we're going to see more and more of this. We've seen a bunch of this with Siemens and some of the things that they've done. I was at one of their shows earlier this year and doing some really interesting stuff with lightweighting and infill materials. Okay, so with that, that's kind of my background. I'm going to call Dave up to the stage and have Dave tell you a little bit about Siemens' journey to the cloud. And thanks, Dave. Here's the thing.
Thank you, Elvis.
Yep.
So, like probably a lot of you in this room, I work for a software company that is a division of Siemens. And one of the things I thought was interesting is that, when we go talk to customers about our different product suites, these are kind of the 9 things that people want to hear. What is your innovation strategy on these things? And so like Elvis was just talking about, things like generative design and 3D printing are on the front of people's minds, but probably not on the minds of the people in this room. The 2 things that you guys probably care about are cloud technology and big data. So even though we typically talk about all 9 of those, today we'll focus on just those first 2. Now, back to the name of this session, right? We talk about Industry 4.0. So let's just talk a little bit about what Industry 4.0 is. So with the 4th Industrial Revolution, we've talked about cyber physical systems, which is basically robots, PLCs, robots talking to each other and do all that data that they generate. Now, Siemens has been around since the 1st Industrial Revolution when we were first beginning to do mechanized construction. through the second industrial revolution when we were doing automation, and through the third industrial revolution when we were using PLCs and robots, but just not connected in a cyber-physical kind of a way. So as you go through those 4 revolutionary steps, what you see is 2 things. Complexity goes up, and all of a sudden the amount of data really starts to increase to the point where now you need big data architected solutions. So if I look about what we've been doing here on the cloud, we've been working with Elvis since about, I think, 2013. And we started our journey to the cloud in the PL division of Siemens in 2012. We actually started in 2011 with a bunch of failures. We tried porting to a bunch of Amazon's competitors, and every one of them was a failure because their platforms just didn't work at that time. And so Amazon was our last vendor on the list that we were going to try. We had no intention of working with Amazon, but since the others didn't work, we thought, well, we had nothing to lose, let's try Amazon. And we were candidly shocked that it worked immediately and fantastically well right from the get-go. So we started to see why other people were moving toward Amazon. So really in 2012, we started having a focus on moving in that direction. And of course, we did kind of those standard steps, certifying the platforms. We started working on our next generation business processes, those sort of things, educating the executives, educating the other product people about what's going on. In 2015, we created a division within PL focused on cloud services to kind of democratize that cloud knowledge that we had with the other business units. And then what you'll also see happen in 2015 is we acquired an asset called Omni. We now call it Product Intelligence. You'll see me use both of those names in this session. And so we acquired Omni, and then in 2015 we moved it from a co-location data center up to Amazon. We'll talk about that journey in the next 20 minutes. And then what we also see is happening is more and more things like the AppStream 2.0 launch. So Amazon did not buy the technology that became AppStream 2.0 because of us, but as a partner we worked with them, talked about our problems, that some of our assets were not really cloud ready to go up in a native fashion, and so we were one of the companies that gave them the feedback that we needed that kind of technology. So what we've seen with Amazon is when we talk to them about our problems and our technology needs, they have a very good track record of responding to those needs. So I work for Siemens PL. It's a $3 billion division of Siemens. We're a software unit, and hopefully you heard in Steve Bishada's keynote this morning, the announcement of MindSphere availability on top of Amazon. But here's kind of our product suite. Now, again, each one of these areas has an SVP that's in charge of that area, and they've got P&L that they've got to manage, and they've got customers that are asking for new features and functions. And we have an extremely conservative customer base. I don't know who your customers are, but in engineering and in manufacturing especially, I can't tell you how conservative our customers are. And so our journey to the cloud has been also a big educational thing that says, even if your customers aren't asking for the cloud yet, they're going to, so we've got to get moving in that direction. So I wanted to show this slide because as soon as we start talking with each one of those product groups about moving to the cloud, we have these standard conversations. Probably every one of you, when you talk about the cloud, has this same virtual slide. Amazon has one, we have one, excuse me. And so we have to go talk to people that say, the reason you want to go to the cloud is ease of IT, faster path to production, simplifying the deployment, and of course, instant scalability. And I use the slide that we had, but if I was writing that slide today, I would change that to elasticity, because really the key thing is not just scaling up, but also scaling down when the demand is not there. And I'll talk to you about our challenges there as we go forward. So this is a slide that we all have, but we have to go through each one of our product groups to kind of explain this slide to them. And I purposely put this slide in, even though the first row probably can't read it, because this is a slide that we have to go through with each one of the product teams in detail to say, okay, where are you in your journey? There's nothing wrong with lift and shift. Some of the things we'll take and lift it and shift it up to the cloud. What do you have that can be native cloud? What are the considerations there? And there's a whole continuum here. So again, I'm not going to talk about this, but these are the detailed conversations we need to have with each one of the product groups when they say that they're going to move to the cloud. So I talked about Omni a little bit ago. This is a big data platform that we acquired into the company in 2015. Now, Omni was a multi-tenant architecture that handled big data. But what happened was it wasn't, designed for the cloud from the point of view of, it wasn't elastic and it wasn't highly available globally. It was in a co-location data center, but it was multi-tenant, Hadoop, and that sort of thing. And so you see across the bottom there, it had a Hadoop-based platform, and you have the rest of the server architecture that came from the development team, but the attitude at this time was open source, right? Now, the challenge, of course, with open source is you got to get it through open source clearance, you got to get legal off your back and let you use it, and then you have to maintain it. You have to keep it up 24/7. You have to handle how to make it highly available. So all those challenges are on you. So we had Omnio, and it was up and going, and it was a successful product, but we made a decision that we did not want to just keep banking on open source that we have to operate. So we made a strategic decision to move it from a co-location data center to Amazon. Now, one of the things that we said, look, if we just took it as is and put it on Amazon, our operating cost would have gone up. Because if you just take, especially a Hadoop-based architecture, and just move it to the cloud without really embracing some of the elasticity of the cloud, your operating costs actually go up versus on-premise. So in order for us to still run a profitable business, we had to really embrace the platform that we are sitting on top of. So you can see on the application interfaces, we chose things like the API gateway, elastic load balancing, kind of the standard things you'd expect us to. For compute resources, you can see the services that we chose, as well as how we did data persistence. And the way it manifests itself is today Omnio, now renamed Product Intelligence as a MindSphere Mind app, is up and running on Amazon. And you can see how now what we've done is, at the end of the day, that Omnio application was also a monolith. Now we're refactoring it into, as you can see here, before it was always modular, but it wasn't microservice-based. So now what we've done is we've changed it to be microservice-based, with each service having its own persistence, leveraging these Amazon features to lower our cost. One of the problems we had before is when this system goes down, well, whose fault is it? Is it IT's fault? Is it engineering's fault? Engineering doesn't want to have to wear a pager for if the system has a system interruption, and IT doesn't necessarily have the expertise to get it up. So the whole point of now moving to serverless and moving to managed resources is now the system is much more self-healing, and now the R&D team is responsible for keeping their system up. It's not throw it over the wall to IT. Now it's they as us. Now we're working in a DevOps mode where IT is the development team, and now the development team is responsible for keeping their microservices up. So that's what we did with Product Intelligence. Now, what you heard this morning in the keynote, hopefully, is that MindSphere has been available. If you noticed that there was a subtlety in what Steve said, MindSphere 3.0 is coming out on Amazon in January. Well, there were two versions of MindSphere before 3.0, and they weren't on Amazon. Now, what we had chosen in the past to do was we really wanted to try to be cloud neutral, because we thought, oh, customers might want it on this platform or that platform. And so we're going to be cloud neutral. We're going to use we're going to use technology that lets us easily port from one cloud to the next. Of course, the problem with that is then you're going at the pace of the slowest horse. When you want to be only use calls that are available on every cloud platform, you're inherently moving as slow as you could go and not leveraging anybody's innovation curve. So what we decided to do this year was to port MindSphere on top of Amazon and embrace those services. And because it's a broader platform than what just Product Intelligence was, you can see that we're using many more of the managed services and many more of managed databases and that sort of thing. And so now the way that manifests itself now is the new architecture for MindSphere is really embracing Amazon, not just happening to run on Amazon, but embracing Amazon so that we can leverage their innovation curve and that velocity. So you can see the services that we use throughout the platform. When we need to get reports out of the system, again, we leverage that same type of architecture to pull that data out, get the reports up to that device that's appropriate. And so the whole point is not that we happen to run on Amazon, but that we embrace the platform to increase our velocity. One of the other products that we're moving on top of Amazon is Manufacturing Intelligence. Now, Manufacturing Intelligence is a product that my team already delivers to the market today, but today it's on-premise, on Windows, on SQL Server. And it's a great product. It works very well. It's got a great UI. But customers have come to us and said, you know, Dave, we've got terabytes of data that we'd like to ingest. We'd really like to manage all this data in Manufacturing Intelligence. And I have to kind of put my tail between my legs and say, well, you know, it's not really a big data architecture. It's in SQL Server. And you know, if you have that kind of data, you really might want to spin that up to the cloud. Do you really have that much storage? And so, you know, Manufacturing Intelligence is a great product, but it doesn't have the benefits of what we're moving toward. So we're partnering with Amazon. We're putting Manufacturing Intelligence up on the cloud. It's coming out the first quarter next year. And you can see the services that we've chosen to use. And the way that manifests itself is like the following. Down on the bottom there, you see these mom applications that we're responsible for, ours and maybe our competitors as well. We ingest that data up through the API gateway into Lambda. We stream it into Kinesis or into S3 and Lambda. It then goes into a data transformation with Glue and with EMR. And then it goes out to one of the persistent data stores. We use QuickSight to get our reports out of there. We use Cognito to do identity management, and then we stream that out to our single page application. And so what happens is we get all the benefits of Amazon's velocity, and we're able to bring that to market very quickly. And just like product intelligence is also becoming a MindSphere Mind app, you'll also, by the end of next year, you'll also see this also available as a MindSphere Mind app. So what's happened since 2012 is we've been starting this journey on the cloud, but at the first, customers were just saying, well, do you run on Amazon? And we'd say, yes, we do, and maybe they would or they wouldn't deploy on Amazon, but it wasn't very key to our business. But what's happened in the over that period, now, if I look back at the last few months, 8 of our largest sales that we've made in the company have all been deployed on the cloud on Amazon in different modes, infrastructure as a service, software as a service, managed services. But the point was, what has happened for us is that Amazon has changed from, just a question of do you support it to we will only purchase your platform if it's running on Amazon, and now it's really having an impact on our bottom line and our revenues, and now everybody's paying attention to that. And so that's kind of our journey that we've been on. Let me bring Elvis back and we can talk about that, and then we'll both be available for questions as well.
Awesome. Thanks, Dave. Well, pretty exciting stuff. So, manufacturing's undergoing a transformation. This is being driven by a number of vectors. The growth of data, the ability to process that data, connectivity, automation, complexity, collaboration. All of this will end up benefiting business, but it will also make the workplace safer and has the potential to actually benefit the environment. At the center of all of this is data, right? Data is the key. And we saw at the beginning that linear product development process is becoming a cycle built around that data with additional services like artificial intelligence. And as we've seen from Dave, AWS has the services and the help that you need to realize the potential of Industry 4.0. And where are we headed from here? Well, personally, I'm very bullish on the future of manufacturing, the democratization of manufacturing, the commoditization of customization, using IoT data and other data to build digital twin models that will drive more efficiency into the manufacturing process and products. Manufacturing is undergoing a transformation, and it's a very exciting time. Thank you all very much.